Token ring IEEE 802.5 standards for token ring. Ring topology used for token ring. Token passing method for access control. Here the problem is device which do transmission first and which device will not transmission now. If all do transmission at the same time, there will be collision. So for that we use token ring passing method. Station which ready with data will hold or capture the token, then start the transmission. After the completion of transmission, release the token. It is unidirectional. Token moves only one direction. It may be clockwise or anti-clockwise. Bandwidth use 4 Mbps and 16 Mbps. We send acknowledgement along with the data. Differential Manchester encoding is used. Static or variable frame size. Monitor station are used because if some frame corrupted in ring, then it simply make traffic, so it remove the corrupt frame. This is the diagram of token ring and how it works. There are 6 stations here. Token rotating in unidirectional, and which station hold the token, they can transfer the data. Then next, there are two types of token passing. One is delay token, second one is early token. Delay token. Sender transmit data packet and waits till the whole packet take the round trip of the ring and return to it. When whole packet received by sender, then release the token. Early token. Token is released as soon as the data is transmitted, not wait for complete rotation. Then next, ring latency. Time taken by single bit to travel around the ring is known as ring latency. RL equals to dV by plus N into B. This is the formula for ring latency. D is length of ring, B is velocity of the data in ring, N is the number of station in ring, B is time taken by each station to hold bit before transmitting it.
Now let's move on to the frame format of token ring. There are mainly two types of frame format. First one is token format, second one is data format. Token format consisting of SD, AC and ED. SD represents the start delimiter, AC represents the axis control and ED means end delimiter. All the three will consisting of 1 byte of data, it means 8 bits. We seen in case of Ethernet, the frame format is like 10001. Likewise, in the case of start delimiter, the frame format is like JK00, JK00. The J will represent the high voltage and K will represent the low voltage. They are the non-data symbols. In case of axis control, the frame format is like 3P, TM and 3R. The starting 3 bytes of P represents the priority and end 3R represents the reservation. And T represents the token is available or not. If the T value is 0, then the token is not available, then it is called as a data format. If the token value is 1, then it is said to be the token format. Then followed by M. M represents the monitor. How many cycles did completed to transfer the data from one token to another will be represented by the monitor. Then finally end delimiter. The end delimiter, the frame format is like JK1, JK1 IE. JK will represent the high and low voltage. I will represent the information or intermediate frame bit, and E will represent the error detection bit. Now let's move on to the data format. The data format consisting of start delimiter, axis control, frame control, destination address, source address, information is called as data. FCS or CRC, it is nothing but cyclic redundancy check, and end delimiter, and followed by FS means frame status. The start delimiter and axis control is same as the token format we read in the token format. It consisting of same 1 byte of data. Frame control were also containing the 1 byte, and destination address will containing the 6 bytes of data. Source address also 6 byte of data, and data or information will be fixed. Like if the data size is large, then it splits into the packets and transfer for the further operation. The FCS or cyclic redundancy check, it helps for the error detection in the data format, and followed by end delimiter we already seen in the token format, and followed by the FS is nothing but the frame status. We move on to the frame control. The frame control frame format is like FF, ZZ, ZZ, ZZ. If the starting value is 00, then it represents the carrying the data. If FF value is 11, it represents the carrying the control signals. Let's move on to the frame status. The frame status frame format is like ACXX, ACXX. The AC value is 10, then it is nothing but first we learn what is the A and what is the C. If A is nothing but the destination data is available or not, is represents the A, and C will represents the whether the data is copied or not. If AC value is 10, then it represents the destination data will be available but not copied. If the AC value is 11, then the destination data is available and copied. If the AC value is 00, then it represents the no destination data and no copied. If the AC value is 101, then it is not possible. By copying also there is no data is available. It is impossible case. It is the information about the data format. Now let's move on to
Token ring physical layer topology. Physically, stations connected to access units which are connected in a ring. All access unit connected to main ring, and each access unit connect with the help of STP link from station to access unit. Token ring networks use two types of connectors. Type 1 IBM connector and Type 3 RJ45 connectors. Token ring physical speed. Initially 4 Mbps speed, mostly now 60 Mbps speed. 100 Mbps speed is standardized but not widely used.
advantages of ring topology. In this, data flow in one direction which reduces the chance of packet collision. In this topology, additional workstations can be added after without impacting performance of the network. Equal access to the resources. These are the advantages of ring topology. Now move on to the disadvantages of ring topology. Due to the unidirectional ring, a data packet or token must have passed through all the nodes. If one workstation shutdowns, it affects whole network or if one node goes down, entire network goes down. It is lower in performance as compared to the bus topology, and it is so expensive. These are the disadvantages of the ring topology.